right, so this is the tentative agenda for this semester. So this is the week of the 10th. So today we'll be introducing the course. We'll do some very basic concepts, defining what a database is in general, and we'll get started already on doing one of the major tasks of creating a database is designing or structuring the database, how to break up the data that we're capturing in its all its constituents and how they relate to one another. Okay? So we'll do that. We'll talk about data definition, data analysis, architecture, and we'll introduce the first assignment well, there'll be two assignments assigned. One of them will be to get you started setting up a development environment, how to set up a Java project, connected to a database, or a remote database, and so that'll be the first assignment, right? To make sure that you have a running local environment where you can actually build something. The next assignment will be it will be more theoretical. You'll be given a requirements, a specification, and then you'll be asked to create a relational database for that specification. Okay, so that's today. We'll do some more next week. We'll do some more theoretical topics on how is it that you build good databases, right? How do you actually structure it? Oftentimes you have domain knowledge on the topic that you're building a database for, so you might have some biases on how data is structured in your head. And so you might already have some opinions on how the database should be set up, right? And that could be a good thing and a bad thing. But really, what we'll try to drive to you is that not necessarily your preconceptions, your knowledge of your domain should drive the design, but mostly it should be driven by the specifications. What are the requirements? What are the end users going to be using the database for? Right, and so what queries are they going to be making, right? And that should drive mostly the design, right? Not necessarily your initial biases. And we'll see how some of these preconceptions of what we might not have about a particular domain can actually work against us, right? Where we have already a structure in our heads, but when we design it, we realize that some of the specifications, some of the requirements cannot be met by what we thought of how to structure the data. All right, so again, we're going to be driving this quite often, that the requirements is what drives the design. Okay. So we'll talk about also normalization, on how is it that you break up the data in such a way to minimize inconsistency. Right? That's another thing that we're going to be driving you for the next couple of months. We're going to eliminate inconsistency, right? By reducing redundancy. We want to eliminate the case where you might query the database in different ways that logically should give you the same answer, and for some reason it doesn't, right? And that certainly can minimize the value that the database might have. And if you're asking a particular forecast on how many products you're going to be selling, or where you should put your investment in, and you're querying your database from your statistical analysis, and asking the question one way, and then asking the same question but in a slightly different way in the database, it should give you the same answer. But if the database does not come to the same answer, you start doubting the database or how it's structured. So it minimizes the value add of the database. So. And usually those problems are the root reason for that is that often we have redundancy in our data, and those redundancies oftentimes where they're supposed to be redundant, meaning they're supposed to be the same data, for some reason it has diverged. You have some conflicting, inconsistent data that minimizes the value. The analogy that I often use is imagine two watches. You have one watch on each side on each wrist, and logically the time should be the same, and most of the times they are, until they're not. right? And you start looking at it, it says, well, which one do you believe? Do you believe the one on the left or you want the one on the right? So this doubt of which one to trust is what diminishes the value of even having a watch, right? Of having two. So ideally, I prefer just to have one, and a broken watch at least is right twice a day. We'll talk about then on actually implementing these databases using SQL as a relational model. We'll spend a couple of weeks working with MySQL by inserting, updating, deleting, grouping, all sorts of operations using SQL. We'll also talk about stored procedures and triggers, all the typical things that you might expect with relational databases. After that, we'll start talking more and more hands-on programming on how to interact with the database programmatically. In particular, we'll look at Java's JDBC, and we'll introduce several design patterns and some best practices on how is it that you interact with the database, such as data access objects and centralizing or modularizing the access to a database. We'll introduce how to interface with data, for instance, with web services and access to an application. In particular, we'll look at web database programming. This XML over here, I'm already thinking that I'm going to move XML to a little later in the course, with the intent that I want to bring NoSQL earlier. I want to bring in NoSQL earlier so that you'll have a better chance at choosing whether you want to go with a NoSQL database or a SQL database, so that you can choose one or the other. So I'm gonna switch these around so that it'll give you a better chance to decide when you get to the project if you want to go one way or another. Okay, so I'll bring NoSQL earlier. We'll talk about implementing web services, a mechanism that allows you to share data across a network with other folks. You're following particular standards, particular schemas that are common with RESTful web services. We'll talk about also implementing, accessing a database from a higher level abstraction using object relational mapping. In particular, we'll look at JPA. And then we'll talk about NoSQL. In particular, we'll talk about MongoDB and creating schemas using Mongoose. And finally, we'll do some transaction management, concurrency, and optimization. Okay.